Scott, do you have an extra copy of these? I was taking a test and I don't have.
How about your piece? Okay, now if I want, I can redraw this before I even start. I want to simplify it. And I'm going to go ahead and add those together. So that's 300. Does that make it easier? We can do this whole thing from this one right here.
Yeah, because your R4 and R5, you're going to combine those together, and then you do X over 1 for those
Yeah.
three parallel.
And you know what? I really don't need to uncombine them until the very last step.
Yeah, and you have to remember to get to add the voltages together, correct?
The two combined voltages have to add up to my voltage drop. So right here, I've basically got, you know, this is a pure parallel circuit in here, but I've got this 180 ohms above it. So I need a resistance total. You all see what I did to these last two, the 125 and 175. They're series to each other, so I'm going to add them up. And I'm going to treat it as one resistor. So now I've got 275, 90, and 300, and we got to do the X over 1. So I'm going to redraw it while you do the math. So tell me what that is. What's my? It's going to be less than 90 ohms. I know that. How much?
55.3.
55.3.
X over 1 plus 3.
So now if you look at this one, it should keep getting easier. You should see these transitions, how I got here. So now this is 45 volts, and it's 125.3, 225.3,
235.
235. Public school math. So now I've got 45 volts and 235.3 ohms. So let's go to the grid first. I'm gonna start over here. I'm gonna write in red what was given to us. So we got 180. I've got two more resistors in there. R4, R5 in total. Turn my screen further. Hopefully that'll help you guys see. So what was given to us was 180, 275, 90, 125, and 175. And then we did the total. So I'm going to put the total in a different color since we did the math on that one. We got 235.3 ohms. Sorry if I'm getting low and has difficulty to see my grid. Maybe I'll write it smaller next time. So we got a voltage total down here. This was given to us, 45 volts. So horizontally, we don't have much to work with except our total. But we need that information anyway. So we can get total current and total power fairly easy. We get current, volts divided by resistance.
And that is 0.191 amps.
0.191 amps.
So the current at your first resistor is going to be that, right?
You are correct. the current for R1 is going to be the same. And that is because everything flows through that 180. Everything flows from our battery through that 180. So this 180 sees the whole current. This is our river before it splits. So now I have two values for R1. I'd like to have the voltage. How much?
34.38.
Okay, so now I'm going to look at this one here because this is, to me, the best place to make sure you see these voltage drops. 34.38 volts. What's my voltage drop for that one there?
10.62.
You sound quite certain.
Yeah.
That was 45 minus 34.2.
So my 34.38, my 10.62 should add up to 45.
So then does the 10.62 for R2 and R3, right?
So yeah, this is, I apologize for not writing them. There's R2, R3, R1, R4, R5. So you are correct. R2 and R3, this is combined. We have this voltage drop from here to here. So the voltage drops, we can carry that 10.62 to 2 and 3.
How'd you get the 10.62 again? Sorry.
Okay.
35.
I have, you see my voltage drop here? That voltage drop is between those red arrows. So I have 10.62. Now, the reason we only gave it to those two is because these two it's really two resistors in series. Now, these two combined are going to add up to 10.62. Because my voltage drop of 10.62 is from here to here, and from here to here, and from here to here. From there, and there. So this one resistor will have 10.62, that one resistor will have 10.62, but these two combined will be 10.62. So
How did you get 10.62? How did you get 10.62?
okay, I got the 10.62 back here because this 500 or 55.3 is the combined resistances of this whole parallel circuit. See, I kind of simplified it here when I combine those two. I got a 275, a 90, and a 300. We do the x over 1. That got us the 55.3. So once I got the voltage drop, I could do the math. I can get this any way I want it. We just subtracted 34.38 from 45, but we could have very easily just taken the current.
I'm still lost on how we got the total resistance.
Okay, the total resistance.
Well, yeah, I know that, but
Okay, you understand how we got from here to here?
but the parallel ones I get.
Okay, but we had the 180 up above.
Right, that's why I'm asking.
So this down here, what was our total resistance? I'm trying to remember.
You mean that?
Yeah, the 55.3 were these, the parallel section. And then we had 180 above it. So we have 180 and 55.3. So this parallel section is in series with the first
Oh, okay.
one, R1.
Okay, I got you.
So R1 is 180 and the bottom section is 55.3. Each have their own voltage drops. See, these are parallel, so they only have one voltage drop. They share the same voltage. So that voltage drop between my red arrows is 10.6. So when we combined these, we add them there in series, we got 235.3 ohms. Then from that, we were able to get the current.
Right.
So I got my voltage drop with 180 ohms in the current. We subtracted, but I could also just used 55.3 in the current and got the voltage. I could have gotten it in two different ways. I'm letting it sink in. So now, what I want to do is get these currents. How do I get the current? I'm going to use this one to get my current. This is where my head's at. To get current, volts divided by resistance. So I've got each of these resistors, C is 1062. These resistors don't know there's a 45 volts because they got shorted. The 180 ohm took 34.38 volts from them, so they only know 10.6. That's the only thing they see.
So was that 10.62 divided by 125?
Yes, it'll be for current. It'll be 10.62 divided by 275.
It's 0.0384.
0.0 what?
0039.
0.0039
For R2?
for
I got
R2.
I got point
I
zero
got
three eight
point
four.
zero three eight.
0.0
Yeah, check out
Point
108.
0.0386.
Yeah, I got
point zero. Tell me again.
point 0384.
0.0386.
Okay. Everybody see how we got that current for R2?
Yep.
We just used the voltage and the resistance. So now let's get the current for the second leg, R2, R3, I think.
0.118.
Okay, so I'm gonna use that 300. Give me a current for this path.
You guys subtract.
Do it the same way.
One subtract by those.
Do it the same way you got these, the 10.62 divided by 300.
0.035.
Why are you using the 10.62?
Because the voltage drop,
It's still the same.
the voltage drop is combined, these two are in series to each other. So there's a little Kirchhoff's law going on inside this parallel. So I'm using this right now because this is my river scenario. This is where it starts, but I have three paths. So really, I'm kind of forgetting. I'm not worried about these right now. I can completely forget that they're separate for now. But I'm going to remember that they are together 300 ohms and they are a path. And the reason I can forget that is because whenever I figure this, what was the current?
0.0354.
0.0354 amps.
So it's gonna be the same for 4 or 5.
Yes, because this is my third path, and the current is going to be the same through those two resistors since they're in series. So this is my two little campsites on this leg of the river, and they're seeing that much current. So now I can go over here, 0.354. 0.354.
4.4.
So now if you look at my grid, I have enough information to solve everything. So what's my voltage for R4?
4.425.
How much?
4.425.
4.425 volts in R5.
6.195.
6.195. Now, I can do a quick double check. These two voltages will add up to what?
10.6.
10.62. That's my check. We can do power just through So I don't no sense in just wearing out our fingers on the calculator.
So I got a lifetime thing.
Okay, I have several of these. Enough to give you dreams at night if I can have it here somewhere.
You see the quiz before the break?
Yeah, we can look at the quiz again. Yes, we can.
You know what it's like.
The quiz you guys took this.
Oh, the quiz.
Yeah, whatever the.
Yeah, the
Midterm.
yeah.
Yeah, okay, man. Did you already hand back that quiz?